Hello friends, welcome to my YouTube channel. My name is Krupesh and we are going to discuss the classification of data structures. There are two types of data structures, primitive and non-primitive. In primitive data structures, integer, character, boolean, float, pointers are mostly used. In non-primitive data structures, linear and non-linear are the two types. In linear data structures, array, linked list, stacks, queue, and in non-linear, tree and graphs are there. So let's see the primitive data structures. Primitive data structure is a data structure that can hold a single value in a specific location, whereas the nonlinear data structure can hold multiple values either in a contiguous location or random location. The example of primitive data structures are a float, character, integer, and pointer. The value to the primitive data structure is provided by the programmer. The following are the four primitive data structures. Integer. The integer data type contains the numeric value. It contains the whole number that can be either negative or positive. When the range of integer data type is not large enough, then in that case we are use long. Float data type that can hold decimal values. When the precision of decimal value increases, then the double data type is used. Boolean data type that can hold either a true or false value. It is mainly used to check the condition. Character is a data type that can hold a single character value, both uppercase and lowercase, such as A as a uppercase, A as a lowercase. Now let's see the non-primitive data structures. Non-primitive data structures are complex data structures that use primitive data structures to form a structure of their own. This is why they are also known as derived types. Inbuilt support is provided for these data structures by many programming languages. They are mostly user-defined. Non-primitive data structures can be further classified into linear and non-linear data structures. In linear data structure, linear data structure sequentially stores the value, that is, each value is linked to the previous one. Following are the categories of linear data structures. Array is a linear data structure. Array stores a collection of data items in a linear sequence and continuous memory location. Each data item is called element. Retrieval of data is easy with the data structures due to the storage of element continuous memory location. Each array element has unique associate index value with which it can be accessed. The size of an array can be expressed mathematically as length element size. Here length is the number of elements in the array and the element size is the memory size of the individual element. Array can be used to store data in tabular format, in financial analysis, in scientific computing, to represent graphs, CPU scheduling, in management system, in libraries, in online ticket booking system, etc. Following is the memory location diagram. In linked list is a data structure which can store a collection of nodes connected together via links, that is pointers. Linked list nodes are not stored at continuous location, rather they are linked using a pointer to the different memory location. A linked list is a dynamic linear data structure whose memory size can be allocated or deallocated to run time based on the operation insertion or deletion, which helps the using system memory efficiency. Let's see the stack. A stack is a linear data structure that follows the last in first out principle. It called LIFO, meaning that the last element added to the stack is the first one to be removed. Following is the diagram which can explain the LIFO for principle. There are many stack operations such as push, pop, top, size, is empty. So let's see the queue. A queue is a linear data structure that follow the first in first out. That's a FIFO principle. In a queue, the first element added is the first one to be removed. Following is a diagram which can explain the FIFO principle. There are many queue operations such as EQ, DQ, peak or font, rear, is full, is null. These are the linear data structures, and now we can see now non-linear data structures. In data structure, a non-linear data structure stand out as a type where elements are not placed in a sequence. Unlike structures like array, stacks, and queue, the array, stack, and queues that add to an order of non-linear data structures arrange information in hierarchical or graphical formats. They enable intricate connection, and streamlined data organization. There are various nonlinear data structures. They are as follows: tree and graphs. Uh, the tree is formed entirely of various nodes and is nonlinear data structures. The following is a diagram which is a representation of a tree. So, a graph is a collection of nodes that consist of data and are connected